How do Tibetans survive winter at 4,000 meters with no wood to burn? Imagine thin air, brutal winds, and nights far below freezing. Fires are scarce, fuel is precious, yet families endure generation after generation. What ancient strategies allow warmth to exist where forests vanish and winter dominates? At high altitude on the Tibetan plateau, trees are rare and firewood is almost non-existent. In this environment, dried yak dung becomes the primary source of heat for daily life. It is not a fallback fuel. It is the foundation of survival, where forests cannot grow and winters last most of the year. Yaks are central to Tibetan life, and their waste becomes a resource rather than refuse. During warmer months, families collect fresh dung from pastures and village paths. It is shaped by hand into flat cakes or compact patties, then laid out on walls, rocks, and rooftops to dry in the intense mountain sun. At 4,000 meters, thin air and strong sunlight remove moisture quickly, turning dung into a lightweight, combustible fuel. Once dried, yak dung burns slowly and steadily. It produces moderate heat without large flames, which suits enclosed stone and earth homes. The fire is usually lit in a simple iron stove or clay hearth placed at the center of the living space. Smoke exits through a roof opening or short chimney. The heat spreads outward, warming people, walls, and floors at the same time. Yak dung is valued because it burns predictably. Unlike wood, which can crack or flare, dung provides a controlled fire that is easier to manage in windy conditions. Families learn how many cakes are needed for cooking, heating, or keeping embers alive overnight. Fuel use follows a rhythm shaped by weather and daily routines. The smell of burning dung is familiar across the plateau. It clings to clothing, walls, and hair. For Tibetans, it signals warmth, food, and safety rather than discomfort. Homes often store large stacks indoors or against exterior walls to protect them from snow and wind. A well-stocked dung pile is as important as food reserves before winter begins. Dung fires also support cooking. Pots of butter tea and barley porridge sit above the same flame that heats the room. Ash from burned dung is collected and reused as insulation or fertilizer, closing the cycle completely. In a land without wood, yak dung turns livestock into energy. It transforms daily herding into heat, meals, and survival. On the frozen plateau, warmth comes from animals, sunlight, and careful preparation rather than forests or power lines. On the Tibetan plateau, warmth does not come only from fire. It comes from walls built to hold heat long after the sun sets. Rammed earth construction, known as gyang, is one of the most important passive heating methods in high-altitude homes where fuel is scarce and winters are severe. These walls are made from local soil mixed with gravel, clay, and sometimes straw. The mixture is packed tightly into wooden forms, layer by layer, then compressed by hand or with heavy tools. Once the forms are removed, the wall hardens into a dense mass that can be more than half a meter thick. This thickness is not decorative. It is deliberate protection against cold, wind, and temperature swings. During the day, sunlight and indoor fires slowly warm the surface of the walls. The dense earth absorbs this heat and stores it deep inside. When night falls and temperatures drop sharply, the stored warmth begins to move back into the living space. This slow release keeps rooms from freezing even when no fire is burning. In high-altitude regions where daytime sun and nighttime cold arrive in extremes, this balance is essential. Rammed earth walls also block wind. On the plateau, cold air moves relentlessly, stripping heat from exposed surfaces. Thick earth walls create a barrier that prevents rapid heat loss. Even when outside winds howl, the interior remains relatively calm and stable. Sound is muted. Drafts are minimal. The home becomes a shelter rather than a struggle. The material itself is easy to source. Builders use soil taken directly from the construction site or nearby land. This reduces the need to transport materials across vast distances. Repairs are simple. Cracks are filled with fresh earth. Walls can be thickened over time as families expand their homes. These walls work in partnership with other heating strategies. Fires warm the air. Sunlight enters through south-facing windows. Floors absorb warmth. The walls hold everything together, acting as thermal anchors that slow heat loss hour by hour. Rammed earth homes age slowly. Their surfaces show layers of history rather than decay. In an environment where modern insulation is unavailable, earth itself becomes insulation. On the Tibetan plateau, gang walls turn soil into stability and mass into warmth that lasts through the longest nights. At high altitude, every source of warmth matters, including the heat produced by living bodies. In many Tibetan homes, livestock are kept on the ground floor during winter. This arrangement is not accidental. It is a practical response to extreme cold, limited fuel, and centuries of adaptation to life on the plateau. Yaks, sheep, goats, and sometimes horses are sheltered in enclosed spaces beneath the family living quarters. These animals generate constant body heat simply by existing. Over hours and days, that warmth accumulates. Heat rises naturally through floors made of packed earth, stone, or wood, warming the rooms above without burning any fuel. The design creates a stable thermal environment. Animals are protected from wind and snow, which helps them survive harsh winters. In return, their presence moderates indoor temperatures for the household. Even a small herd can raise the temperature of upper rooms by several degrees. At night, when outside temperatures plunge, this passive heat becomes especially valuable. Floors between levels are built thick to allow slow heat transfer rather than rapid loss. Warmth seeps upward steadily instead of escaping all at once. Families sleeping above feel less of the biting cold that dominates the open plateau. Combined with heavy rugs and wool bedding, this subtle warmth helps prevent dangerous drops in body temperature. This system also fits daily life. Livestock are close at hand for feeding, milking, and care. Waste is easily collected and later dried for fuel. Nothing is separated from survival. Heat, food, labor, and shelter remain part of the same cycle. Ventilation is carefully managed. Small openings allow fresh air to circulate while limiting heat loss. Odors are accepted as part of winter life. Cleanliness focuses on function rather than comfort. Animal body heat does not replace fires. It reduces how often they are needed. In a land where fuel must be gathered by hand, this matters deeply. On the Tibetan plateau, survival depends on using every available resource. Even warmth from breathing animals becomes part of the architecture of endurance. For decades, Tibetans have used the intense, high-altitude sun as a source of heat and energy. Solar cookers are a practical response to life at 4,000 meters, where fuel is scarce, trees do not grow, and sunlight remains strong even in freezing weather. In many plateau communities, solar cooking has become one of the most reliable ways to reduce fuel use without sacrificing daily meals. The system works by concentrating sunlight onto a cooking surface. Reflective metal panels or mirrored dishes are angled toward the sun, directing light into a central pot. Some designs use insulated boxes with transparent lids that trap heat inside. Once positioned correctly, the cooker requires no fire, no fuel, and no constant supervision. At high elevation, solar radiation is powerful enough to boil water and cook food even when air temperatures stay well below freezing. Families prepare butter tea, soups, and grains outdoors during daylight hours. This shifts much of the cooking process away from indoor stoves, preserving yak-dung and other fuels for heating homes at night. Solar cooking creates a rhythm tied closely to the sun. Meals are planned for clear hours. Water is heated in large quantities and stored in insulated containers to retain warmth after sunset. When clouds arrive or storms move in, families return to traditional stoves, but every sunny day saves valuable fuel. Homes and courtyards are arranged to support this method. Flat roofs, open yards, and south-facing spaces provide stable platforms for cookers. Some households modify designs using scrap metal, polished aluminum, or broken mirrors. Repairs are simple, and materials are locally available. Solar cookers do not warm living spaces directly. Their importance lies in what they preserve. By reducing daytime fuel use, they ensure fires can burn longer when darkness and cold arrive. On the Tibetan plateau, sunlight becomes a daily resource. It feeds families, protects fuel reserves, and quietly supports survival in a land without wood. In the thin air of the Tibetan plateau, sunlight becomes a vital source of heat. With limited fuel and long, freezing winters, Tibetan homes rely on south-facing windows to draw warmth directly from the sun. This passive method turns clear skies into daily protection against cold. The approach is rooted in orientation. Houses are positioned so their largest windows face south, capturing low winter sunlight for much of the day. At high elevation, solar radiation is strong and unobstructed. Sunlight travels deep into living spaces and strikes floors, walls, and raised platforms made of earth and stone. These interior surfaces absorb heat slowly throughout daylight hours. Their density allows them to store warmth rather than release it immediately. When night falls and outside temperatures drop rapidly, the stored heat radiates back into the room. This steady release reduces dependence on constant fire and keeps indoor spaces from reaching dangerous cold. Window size and number are carefully controlled. Openings must gather enough sunlight without allowing excessive heat loss after sunset. In the evening, families cover windows with thick cloth, felt mats, or wooden shutters. These layers block wind and seal warmth inside through the coldest hours. Daily life shifts towards sunlit areas. Families eat, work, and rest where light reaches longest. Bedding is often placed near windows during the day so it can absorb heat before night use. Elders and children remain close to these warm zones during winter. This system requires no machinery and no fuel. It depends entirely on knowledge of seasonal light and simple building choices. On the Tibetan plateau, sunlight becomes part of the home itself. Through careful design, homes store daylight as warmth, carrying families through freezing nights. Across windswept grazing lands and clustered stone villages, heating begins with livestock rather than fuel depots. Sheep dung pellets are a common winter resource in areas where trees do not grow and imported fuel is unreliable. These small, dense pellets provide dependable heat through careful use and long practice. Sheep naturally produce dry, compact droppings that require little preparation. During spring and summer, families collect pellets from pastures and paths while tending herds. The material is gathered by hand and stored in sacks, baskets, or low stone enclosures. Thin air and strong sunlight dry the pellets quickly, turning waste into burnable fuel with minimal effort. When burned, sheep dung pellets ignite easily and release heat quickly. They burn hotter than yak-dung, but do not last as long. This makes them well suited for short tasks such as heating water, reviving embers, or raising room temperature during the coldest hours before dawn. Many households combine pellets with slower burning fuels to maintain steady warmth. Pellets are usually burned in small iron stoves or clay hearths set near the center of the home. Their uniform size allows precise control over heat. A few pellets can increase warmth without overheating the space or producing excessive smoke. This precision matters in tightly sealed rooms where airflow must be limited to retain heat. Storage is straightforward and efficient. Pellets remain dry and clean compared to other fuels. Many families keep baskets near the stove for easy access during the night. A full supply offers reassurance during storms and prolonged cold spells. Ash from burned pellets is collected and reused. It is spread on floors for insulation, mixed into soil, or added to wall layers to reduce moisture. Nothing is wasted. In cold landscapes shaped by altitude and scarcity, sheep provide more than food and fiber. Their waste becomes heat. Survival depends on using every resource fully and carefully. In cold mountain homes, warmth is built layer by layer. Woolen tapestries and rugs play a critical role in retaining heat, especially in environments where floors and walls are made from stone or packed earth. These textiles turn living spaces into insulated shelters without relying on fuel. Sheep and yaks provide thick wool that is spun, woven, and felted into dense fabrics. Rugs are laid directly on earthen or stone floors where cold would otherwise rise into the body. The wool traps air within its fibers, slowing heat transfer and reducing the chilling effect of contact with the ground. Even a single layer can make the difference between comfort and numbness during long winter nights. Tapestries are hung on interior walls, particularly those facing prevailing winds. These fabric layers add insulation where walls lose heat fastest. They also protect living spaces from drafts that seep through cracks in stone or earth construction. In homes with minimal heating, reducing airflow is as important as generating heat. Daily life revolves around these textiles. Families sit, eat, work, and sleep on rugs placed near the warmest parts of the home. Bedding is layered directly on top of them at night. During the day, rugs are aired in sunlight to remove moisture and restore loft, preserving their insulating ability. The weight of wool matters. Heavy rugs stay in place and hold warmth close to the floor. They absorb heat from stoves and sunlight, then release it slowly over time. This creates a stable microclimate where people spend most of their hours during winter. Woolen textiles are durable and repairable. Frayed edges are stitched, worn sections are patched. Old rugs are stacked beneath newer ones, increasing insulation rather than being discarded. Over years, homes accumulate layers that reflect both use and survival. These rugs do more than decorate. They protect bodies from cold surfaces and slow heat loss hour after hour. In harsh climates, wool becomes architecture. It shapes how warmth is held, shared, and preserved when resources are limited. In regions where the earth itself releases heat, Tibetans rely on geothermal energy as a natural source of warmth. This method appears in areas shaped by tectonic activity, where underground heat reaches the surface and offers relief from extreme cold without the need for fuel. Hot springs are the most visible expression of this energy. Warm water flows year-round, remaining unfrozen even during the harshest winters. Nearby households guide this water into stone basins and shallow channels to support daily life. The warmth is used for washing, food preparation, and heating living spaces, reducing dependence on dung fires. In parts of western Tibet and areas around geothermal fields such as Yangbajing and Damsung, naturally hot water is sometimes channeled through shallow stone channels near or beneath living platforms. These channels warm stone and earth surfaces rather than circulating through sealed pipes. People sit and sleep above these warmed areas, using the retained heat much like a floor heater. The system relies entirely on gravity and natural flow, with no pumps or fuel involved. Some homes are built directly over geothermally warmed ground. Thick floors made from stone and packed earth absorb heat from below and release it slowly into rooms above. This passive warmth does not raise indoor temperatures dramatically, but it prevents spaces from freezing during long winter nights. Geothermal heat also supports animals and stored food. Warm water keeps washing areas usable and prevents supplies from freezing solid. Shared pools allow families to access heat collectively with simple rules to avoid waste. The infrastructure remains minimal. Channels are cleared by hand. Stones are reset when needed. No complex systems are involved. Geothermal heating reflects a close relationship with the land. Instead of bringing fuel to the home, families settle where warmth already exists. In extreme cold, the ground itself becomes a steady and reliable source of heat. In parts of central and eastern Tibet, especially around Lhasa, Shigatse, and the Yarlung Tsangpo Valley, greenhouse sunrooms are added to homes to capture and store solar heat. In these regions, winters are long and fuel is limited, but clear skies provide strong sunlight for much of the year. A greenhouse sunroom is usually built on the south-facing side of a house. Walls are made from glass, plastic sheeting, or translucent panels. During daylight hours, sunlight enters freely and becomes trapped inside. Air temperature rises well above outdoor levels, even when snow remains on the ground. The system works through heat storage. Stone floors, earth walls, water containers, and stacked bricks inside the sunroom absorb warmth throughout the day. When night falls and temperatures drop sharply, this stored heat is released slowly. Doors or vents connecting the sunroom to the main living space allow families to control how and when warmth moves indoors. Sunrooms also reduce heat loss. By creating an enclosed buffer zone, they shield the main house from cold winds. Air entering the living space is already warmer, and less heat escapes outward through exterior walls. These spaces serve multiple functions. Bedding and clothing are dried in sunlight. Fuel stores remain unfrozen. In some households, vegetables or fodder plants are grown inside during winter months, adding resilience to food supplies. Construction remains simple. Frames are built from wood or scrap metal. Panels are replaced as they wear out. No machinery is involved. Greenhouse sunrooms do not replace traditional heating. They reduce fuel consumption and extend warmth into the night. In sun-rich valleys of Tibet, architecture itself captures daylight and turns it into survival heat. At high elevation, sunlight is one of the few resources that remains abundant year-round. Photovoltaic solar panels convert this constant exposure into electricity, providing limited but reliable energy in regions far from centralized power grids. While they do not heat homes directly, they play an important supporting role in winter survival. Solar panels are installed on rooftops, poles, or open ground where they face the sun for most of the day. Thin air and clear skies increase solar intensity, allowing panels to perform efficiently even in cold temperatures. Electricity generated during daylight hours is stored in batteries for later use, especially at night. This stored power supports essential heating-related needs. Electric lights reduce the need for indoor fires after dark. Small electric heaters or warming plates are sometimes used to prevent freezing in critical areas. Most commonly, electricity powers kettles, hot plates, and water heaters that reduce the amount of dung or biomass needed for cooking and warmth. Solar power also supports communication and coordination during winter. Radios, phones, and small devices stay charged, allowing families to receive weather information and stay connected during storms. This reduces isolation and risk in remote areas. Panels are often introduced through local programs, monasteries, or community projects. Over time, households adapt systems to their needs. Wiring is simple. Repairs are done locally. Batteries are protected indoors to prevent damage from cold. Systems are sized carefully, focusing on reliability rather than abundance. Solar electricity changes how fuel is used. By shifting certain tasks away from fires, it preserves dung and biomass for heating during the coldest hours. This balance is critical in winter, when fuel collection is difficult and reserves must last months. Photovoltaic panels do not replace traditional heating methods. They strengthen them. They provide light, support heat retention, and reduce waste of physical fuel. In sun-rich highlands, electricity comes not from distant plants, but from rooftops and open ground. Solar panels turn light into stability, helping families endure winter with fewer fires and greater control over limited resources. In regions where grasslands give way to wetlands, the ground itself becomes fuel. Dried peat and turf are used for heating in parts of eastern Tibet and the northeastern plateau, particularly around the Zoega marshes, also known as Ruorgai, and areas of Nagku and Amdo. In these cold, treeless landscapes, peat replaces wood as a reliable source of winter heat. Peat forms over centuries as grasses and plants decay slowly in waterlogged soil. In summer and early autumn, families cut blocks of turf from exposed peatlands using simple tools. The blocks are laid out to dry in the sun and wind until they become light enough to burn. Once dried, peat is stacked near homes or stored in sheds to protect it from snow and moisture. When burned, dried peat produces a steady, low flame and long-lasting heat. It burns slower than sheep dung and with more endurance than loose biomass. This makes it well suited for overnight heating or maintaining embers through long winter evenings. Peat is commonly used in iron stoves or enclosed hearths where airflow can be carefully controlled. Peat smoke is dense and carries a strong smell, so ventilation is essential. Chimneys and roof vents are kept clear throughout winter. Despite the smoke, peat remains valuable because it provides consistent heat when other fuels run short. Families often mix peat with dung to balance burn speed and intensity. Peat also works well with thermal mass. Stone floors and thick walls absorb the slow heat and release it gradually, keeping rooms warmer long after the fire dies down. This reduces the need for frequent refueling, which is especially important during storms or deep snow. Collecting peat is labor-intensive and increasingly regulated due to environmental concerns. Where it is still permitted, use is careful and seasonal. Families cut only what they need and rely on shared knowledge to protect grazing land. In wet highland regions where trees cannot survive, peat turns soil into warmth. It represents another way people adapt to the land they inhabit. When winter tightens its grip, even ancient layers of earth are called upon to keep homes alive. Tibet shows how winter survival takes shape at extreme altitude, where heat comes from land, animals, and sun. But Tibet is only one part of China. Beyond the plateau, climates shift and resources change. How do people across China survive winter without gas or electricity in places nothing like Tibet?